All right, lesson 2.7, solving equations with variables on both sides. So let's go back to a little bit from our previous lesson. And what I didn't show was how do you check after you find the solution? How do you check that the solution works? How do you check that x equals 3 is the correct solution to this equation right here? Okay, the way you check is by replacing x equals 3 with x on the left side of the equation and checking to see if it's going to equal the right side of the equation. So if I do that here, I'm going to say negative 4 times my x, which is 3. So I'm going to replace x with 3. And I put that in brackets. Every time I replace a variable, I put it in brackets. And then I put plus 12. Okay, so negative 4 times 3 plus 12. And if I evaluate this using BEDMAS rules, multiplication first, negative 4 times positive 3 is negative 12. And don't forget, I am adding 12. And together, that makes 0. Okay, and unfortunately, the right side is equal to 24. And 0 is not the same thing as 24. So unfortunately, the left side is not equal to the right side. So this is how you draw the not equal symbol. So drawing an equal sign with a line strike through it. And so x equals 3 is not a solution to this equation. There might be other solutions that are correct, but x equals 3 is not one of them. So it's important to check your solutions after you solve the equation to see if your work was correct. Now let's look at a different kind of equation here. So here, this is something different than yesterday or the other lesson. Now have two. I have two terms here with the variable in it. So I have the variable on both the left side and the right side. So in a situation like this, you want to have your variable on one side of the equation. Okay, so that means I may have to try and get rid of this other variable here if I want to keep this one on the left. Okay, so I'm going to get rid of the 2k here by subtracting 2k on both sides of the equation, because whatever you do on one side, you have to do on the other to balance it. So if I subtract 2k over here on the right, 2k take away 2k is 0, and I'm left with 7, so I have to put 7 here. And on the left side, I have 5k minus 2k, which is 3k, and then I have my minus 8. And so now I have taken this equation with a variable on both sides of the equal sign, and I've reduced it down to just an equation with just the variable on the one side. And then everything that you see here is the same thing like we did in the last lesson. So reverse BEDMAS. Before you do the multiplication, you have to take care of this subtraction. Okay, so if I have a subtraction of 8, to get rid of this minus 8, I do the reverse operation. I'm going to add 8. And you must do it on both sides so that you balance the equation. Okay, so if I add 8, so negative 8 plus 8 is 0, and all I have left on the left side is just 3k. Equal sign, 7 plus 8 is 15. Again, notice how I'm lining up my equal signs, and notice how I'm not starting off every line with an equal sign, because I'm not evaluating or simplifying an expression here. I'm just solving an equation. So you cannot have two equal signs on the same line. So I have this one equal sign here, and that's good enough. So I'm stating here in math that the left side is equal to the right side. Okay, every time we wrote an equal sign in the beginning, that always signified that the whatever I'm writing on this line is equivalent to the line that came before it. Okay, that's why we wrote an equal sign always in the beginning, because we were dealing with expressions. Here, the equal sign is now in the middle. Okay, so continuing on. So I have now 3k. If I want to isolate my variable, I have to divide by 3. So divide this side by 3, balance it by dividing the other side by 3. It's also important to make sure you line up your equal sign with the fraction lines. That's also good form. Okay, so 3 divided by 3 is 1, leaving me with k, equals 15 over 3 is 5. Okay, so just to recap here in your notes to make sure you understand what's happening in each step, I'm going to write here that we are subtracting 2k from each side. Here in this step, we are adding 8 to both sides. And over here, I'm dividing both sides by 3. Okay, so as you can see, I'm following reverse operations in order to solve this equation. Okay, now that you have k equals 5, always make sure you check your work, check to see if this is the correct answer, and to do that, I'm going to compare the left side with the right side. Okay, on the left side we have 5k minus 8. So I'm going to write here 5k minus 8. I'm going to replace the k with 5. So 5 times 5 minus 8. 5 times 5 is 25, minus 8 is 17. Okay, so on the right side, I have 2k plus 7. So I'm going to write 2k plus 7. And that equals 2 times 5. When I replace k with 5, plus 7. 2 times 5 is 10, plus 7 is 17. And it turns out the left side of my equation is equal to the right side of my equation. So I'm going to say that here. Left side equals right side. That means I just checked my answer at k equals 5 is the correct solution. Okay. If they were not equal, then this statement cannot be true if k equals 5. We'd have to look for something else. We have to check to see if there's a mistake in our work. Let's go to part B. Again, I have a variable here on both sides of the equation. 5 minus 3m equals negative 2 minus 2m. So I'm going to try and remove one of these terms. Okay, so I'm going to choose to remove the minus 2m by adding 2m here. And I have to balance the equation, so I have to add 2m over here. Okay, so minus 3m plus 2m is minus m. I still have a 5 in the front. And on the right side, I have negative 2. Negative 2m plus 2m is 0. So all I have is negative 2 on the right side. Okay, so now I'm down to an equation with one variable on the left side. Simplify. I have to isolate the variable. So I have to remove the 5. So if I remove the 5, I'm going to subtract 5. Balance it by subtracting 5 on the other side. So 5 take away 5 is 0. All I have is negative m equals negative 2 take away 5 is negative 7. So negative m equals negative 7. So to get the positive value, I'll just multiply both sides by negative 1. Multiply this side by negative 1. And negative 1 times negative m is positive m. Negative 7 times negative 1 is positive 7. And there you go. My solution is m equals 7. Now, of course, you check to make sure the left side is equal to right side. And to make sure there's no mistakes in your solution. Okay, part C. Now, here's one question where you notice we have, again, the variable repeats itself on the left side, but we now have a monomial times a binomial, okay? And when you see that, you have to expand. So your first step in this kind of equation would be to expand. Okay, so if I expand this, I have 5 times y, which is 5y. 5 times minus 3, which is minus 15. Don't forget there's an invisible 1 here. So minus 1 times y is minus y. And then minus 1 times minus 2 is positive 2 equals 19. Okay, so your next step would be to collect like terms. So 5y minus y is 4y. Negative 15 plus 2 is negative 13. Maybe I should have written closer, so I'm going to line up my equal signs. So 19 over here on the right, and I have positive 4. So 4y minus 17, or minus 13. Okay, then I'm going to, now again, the goal is to isolate y. And to do that, I have to remove the minus 13 first. I can't do the multiplication yet. It's reverse bedmass. Take care of the addition and subtraction. So here I have a subtraction. Minus 13, reverse operation, plus 13. Both sides, plus 13. Okay? So here I have 4y equals 19 plus 13 is 32. Negative 13 plus 13 is 0, so that's why I have just 4y on the left. Now, if I want to isolate y, the last step would be to divide both sides by 4. Okay, 4 over 4 cancel out and become 1. Y equals 32 over 4 is 8. And there's my answer. Okay, now last example, again we have a binomial and a monomial being multiplied both on the left and on the right. So the first thing we have to do is expand, use the distributive property. So when I multiply that 4, remember, 4 only gets multiplied with the terms inside, okay, inside the bracket. You're not going to multiply the 4 with this minus 2 outside. It's only the things that they are attached to. The binomial it is attached to on the inside. Okay, so I have 4 times x, which is 4x. 4 times 2, which is 8, so plus 8. Outside I have the minus 2 equals. Here I have 2 times x, which is 2x. And then 2 times minus 2, which is minus 4. Then I have the plus 4 on the outside. Okay. Let's try and simplify things a little bit. 8 take away 2 is 6. I have the 4x out in front. And then the plus sign between those two terms. On the right side, I have 2x. And negative 4 plus 4 is 0. Okay, so 2x is the only thing I have on the right side. Now again, here's a situation where we have a variable on the left and on the right. So I want to just get to one variable to deal with. So I have to maybe subtract 2x from both sides. So if I subtract 2x here and if I subtract 2x here to balance the equation, then these two go away and I'm left with 0 on the right side. So even if they'll go away, you have to put it in the 0 because you have this is an equation. It has to equal something. So I'm going to say that this equals 0. Okay, 4x minus 2x is 2x. And then I have plus 6. Okay, 2x plus 6 is equal to 0. Now, next step, reverse operations. So addition before the multiplication. So to get rid of positive 6, I'm going to subtract 6 from both sides. And I'm left with 2x on the left. 6 minus take away 6 is 0. And then 0 take away 6 is going to be negative 6. Okay, 2x equals negative 6. I want to get the x isolated, so I divide both sides by 2. And that leaves me with 2 over 2, which is 1. And that leaves me with x. And then negative 6 over 2, or divided by 2, is negative 3. And there's my solution. And now we're done this lesson.